I'm pleased to have your attention. My name is meysam.shamsi and I'm gonna talk about TTS corpus design. This study has been done by Dr. Chevelu, Dr. Barbot, Dr. Lolive and me in ERISA Institute. Let's start with introduction and explanation of paper's idea. Text-to-speech system which converts a given script to synthetic signal could be a solution for audiobook generation. It helps to reduce the cost. The voice corpus is a crucial part of TTS systems. It could impact on the quality of synthetic signals. On the other hand, optimizing this part could limit the recording and annotation costs. In previous studies, there are some solutions for this optimization. Usually, this problem is defined as a subset selection. These works can be categorized into two groups. The idea in the first group is based on coverage of units. The second group tries to focus on distribution of units. For example, they try to increase the entropy or decrease the Kullback-Leibler divergence to have a similar distribution with a target distribution. By investigation in previous works, we have found out a tendency of voice corpus design to select short utterances. For example, in a study by François and Boefa, the average length of extracted subcorpus is 20 phonemes per sentence, out of an initial corpus with average length of 74. This trend also can be observed in other studies. It could be claimed that this would be a bias of the algorithm, not a trend from the data to achieve better quality. But in our previous study, a completely unsupervised method also selects shorter utterances. In our previous work, objective and subjective evaluations of synthetic signal quality have shown that our proposed method, called CNN k-means, outperformed the set covering method. By looking at average lengths of selected utterances in different subcorpus sizes, we can see this method contains shorter utterances. Also, by reducing the subcorpus size, the average lengths of utterances are declined. So the objective question of this study could be precised as if the selection of the shortest utterances is always the best strategy for voice corpus design, is this tendency a consequence of the optimization or a cause of the good results? We simulate voice corpus design on two different audiobooks and two TTS engines to test this hypothesis. Is the shortest utterance always the best? Let's talk about the TTS systems, data, and the voice corpus design algorithm that we use. In order to examine corpus design methods, we use two kinds of unit selection based TTS. An expert TTS, which its weight for calculating global cost based on target and concatenation cost, are manually tuned by expert. The second TTS is a hybrid TTS which uses a trained neural network for calculating target cost. We simulate the process of voice corpus design by using two different audiobooks with same total length. Pod corpus is recorded by a male speaker and contains long utterances, but NAD corpus is recorded by female speaker and contains short utterances. We implement 4 algorithms to extract a subset of utterances for these corpora. A random selection as a baseline, a greedy process for coverage of diaphone labels plus 20 other linguistic features, which more detail related to this method can be found in our previous paper. The third method, called CNN k-means, which uses a CNN autoencoder to transform features. Afterward, the embedding vector of utterances will be clustered and finally the closest utterances to cluster center will be selected. The last method is simply selecting the shortest utterance in a loop until the desired length is satisfied. These methods are compared based on objective measures, and finally we run a perceptual test. Each audiobook has divided in two parts, a test part and a part which called full corpus. The division has been done in tenfold cross-validation. The reduction algorithm selects 10% of each full corpus as a TTS voice corpus. The selected subcorpus is used to synthesize corresponding test section. It means tenfold cross-validation provides the whole of each book in synthetic format with different TTSs and different methods. It's not possible to compare all signals perceptually, so we use TTS costs to approximate the synthetic quality. The target and concatenation costs of an utterance, which are normalized by its length, are a good approximation of overall quality. Based on objective measures, two best corpus design methods are compared perceptually in an A/B test. The lengths of some utterances are so long, and it's not a good idea to ask listeners to compare long signals. So utterances are split into breath groups. By using DTW techniques, similar signals resulted by two best methods are filtered, and afterward 50 pairs has been selected randomly for each book TTS system. The listeners asked to do 40 comparison in 5 preference point scale. You can see the perceptual test platform and two examples of comparisons.
Mais pour ma raison, à qui la seule explication de certaines mauvaises humeurs. Mais pour ma raison, à qui la seule explication de certaines mauvaises humeurs.
Repartit Patou, et rien ne m'ôtera de l'idée qu'il y a là, monsieur, sous quelque diablerie. Repartit Patou, et rien ne m'ôtera de l'idée qu'il y a là-dessous quelque diablerie.
Let's talk about experimental results. This figure shows TTS concatenation cost of synthetic signals. It can be seen that shortest methods succeed to synthesize signals with lower concatenation cost in both books and both TTS systems. The same situation can be found for TTS global cost, which is a combination of target and concatenation costs. Lower TTS cost for the shortest method approximates higher synthetic quality. Based on these objective measures, we run the perceptual test to compare shortest method with the second best method, which is the CNN k-means. The perceptual test confirms the objective measures results. The results show shortest method has been preferred at least slightly for both book and both TTS systems. The preferences can be distinguished easily by converting the results to simple A/B test with 3-point scale. After this observation, we decide to investigate more into results. As we mentioned before, the coverage rate and distribution-based metrics were the classical measures for corpus design. So we calculate the diaphone and triphone coverage rate of resulted subcorpus by different methods. A same coverage rate of shortest method and CNN k-means or random methods indicated the short utterances don't contain a set of specific units, and they are as good as random in terms of unit coverage for 1 hour of subcorpus. By calculating Kullback-Leibler divergence, it's observed that the shortest method does not respect the general distribution of corpora, while the random selection method achieves the lowest Kullback-Leibler divergence. These statistics reveal that the shortest method could be successful. However, in terms of these metrics, is not even as good as random. As a first investigation inside short utterances properties, we find more variation of F0 in the voice corpus obtained by the shortest method than others. It has been mentioned by some previous papers that short utterances are often more expressive and have a different prosodic delivery. Needless to say that short utterances are easier to read and record by speakers. To sum up this study, we evaluated a simple hypothesis for corpus design with 2 different books and 2 different TTS systems. The results show that selecting short utterances could work well for TTS voice corpus design. The perceptual test confirms this hypothesis. However, some metrics such as coverage rate and Kullback-Leibler divergence does not show any superiority of shortest method. Thank you for your attention.